Okay, so today I will show you how to create a simple keypad using the Arduino Uno, the OLED display and 16 push buttons. And I can press those buttons to enter some secret code. And not only I can use numbers, but for example also those A, B, C, D buttons or even the asterisk. I have two versions, one with slightly smaller display and the other one with slightly bigger display. Also, I have this project powered by batteries, so you can just put it anywhere you want. And based on my calculations, they should last at least 100 hours. Now the sponsor of today's video is TEMU, because all the components that I will be using today are from TEMU. So let's go to the TEMU website and let's start with getting the Arduino board. And I will go with my favorite one, which is the Arduino Uno. For example, this one, or maybe this one is even cheaper. And it looks like I can select between the version with this big USB port or the USB-C port. And this cheap Uno has something that even the official one is missing, and that's this second row of header pins. So if you want, you can solder the male pins in there. The next thing that I need is the OLED display, and I have dozens of videos using OLED displays with the Arduino Uno. My favorite one is the 128 by 64 pixel resolution monochrome OLED display using the SSD 1306 chip. And sure enough, if I search for the Arduino OLED on the TEMU website, this is the OLED display that I'm looking for. And the price seems to be a little bit too high, but that's because this is the price for 5 pieces. But if you want to save more money, you can use the link down in the description to download the TEMU application, or use this code in the TEMU application, and that should give you €100 coupon. So you should be able to get all those components for much lower price. Also, I believe that if you don't have the TEMU application just yet, you should be able to purchase one of those components for only €1. But back to our OLED displays, I can choose between the blue one, the white one, and the combination of yellow and blue, where the top of the display is yellow and the bottom of the display is blue. But I will go with the white color. And let's actually also get those displays which are slightly bigger. This is saying 3.3 centimeters, I believe that's 1.3 inches. Finally, we need some jumper wires to connect everything together. And there are a lot of jumper wires that you can choose from, but I will actually go with this package, because not only you have jumper wires, but also the breadboard and few other components, and everything is inside this nice little box. In the end, those are all the components that I did get from TEMU for today's project, although I might not be using all of them today. Definitely not all the components from this box, but it's nice to have all the wires and actually the breadboard with the breadboard wires, that's always handy. The Arduino Uno came with those male header pins, so you can solder them if you want to. The USB cable actually matches the Arduino Uno, but it wasn't included with the Uno, it was included with those battery packs. And I did get the version for 1 battery and for 2 batteries, together with those two 18650 batteries. And to find out how long I can power up my project using those batteries, I did get this USB tester. Obviously the keypad with the smaller and the bigger display, that's the main part of today's project. But since you can never have enough OLED displays, I did get 5 of those bigger displays, those are 1.3 inches. And 5 of those smaller displays, those are 0.96 inches. I also did get this board, which is kind of cool because it uses the very same chip as the Arduino Uno. So once you get the project working on the Arduino Uno, you should be able to make it work also with this smaller board. And of course the size will be the biggest advantage. So those are all the components, and let's get back to our project. So I think that now we have everything we need to get started. So let's connect the OLED display to the Arduino Uno board, and we should connect the ground to ground, the VCC to 5 volts, and the SDA, the serial data, to pin A4, and SCL, the serial clock, to pin A5. And again, I have a lot of different videos using this display, for example this one. It's called Image to OLED in 60 seconds, using the very same OLED display and the Arduino Uno board. And there is a link to the walkway sketch. And Walkway is a free online Arduino emulator, so we can see what's going on. We can also see the connection in here, and it's really just showing one full screen image on the OLED display, but I think it's a good start, so let's just copy the code into the clipboard. Then open the Arduino IDE and paste the code in here. Connect the Arduino board to the PC and then go to Tools, Board, Arduino Boards and select the Arduino Uno. And as for the port, it will most likely be the last one. And then click the Upload button. And if everything is connected properly, we should see the image on this small OLED display. And that's great, but we don't want to show the menu, we want to show the keypad for entering the pin code. So before doing anything else, let's create a new full screen image. And for that I will use a tool called Photopea, which is a free online graphic editor similar to Photoshop. And in here, I will create a new image in the size of 128 by 64 pixels with the black background and hit the create button and then zoom in because it's quite small. And in here, I want to add some labels using the type tool. So type in something, for example, 1, 2, 3, 4. And as for the font, I want to use some font that I can later use inside of the U8G2 library, which is the library being used for drawing stuff on the display. And if I open the fonts which are available for the U8G2 library, I quite like this one, which is called Pro Font. And there is actually a link to the website where you can download this font for Windows. You can even change the font size on this website. So let's just make it slightly bigger and search for the Windows version. And I want to download this Pro Font TTF tweaked. So click the zip file to download it. And then back inside Photopea, I will keep the type tool selected and open the drop-down menu for fonts and click the load font button. And select that TTF font. I want to also use it the next time, so click the OK button. And then open the drop-down menu again and select that font, which is the Pro Font Windows. And I will increase the size to be 24 pixels and change the anti-aliasing method to none, because we cannot display grayscale pixels on the display, we can only display black or white colors. Let's move this layer around a little bit and give it some outline by creating a new layer and then selecting the rectangular selection tool and select the area around the label, for example like this, and then go to Edit Stroke. And I want to edit the 2 pixel stroke on the outside in the white color, so hit the OK button. And you can see we have again some grayscale pixels, and the easiest way how to get rid of those is to add a new effect, being the threshold effect. And using this slider, you can set which of those pixels should be displayed and which shouldn't be displayed. And I will keep it somewhere in the middle, like so. And then I want to visualize the keypad on the right side of the display. And for that, I will create a new label and start with the number 1 and make it smaller, for example, only 12 pixels. And then move it around and then create a copy. And you can create a copy in a few different ways. For example, right-click the layer and select duplicate layer. And then move it around. If I press the arrow key, it will move it by 1 pixel. And if I press the arrow key together with the shift key, it will move it by 10 pixels. So for example, move it by 13 pixels on the right side. Then double click the layer thumbnail and change the content to be digit number 2. And the other way how to create a copy is to press the Alt key together with the Shift key and together with the right arrow, and that will create a copy and move it 10 pixels to the right side. So 1, 2, 3 to move it 13 pixels, change the content to be digit number 3 and do it one more time, but this time it will not be the digit number 4, but instead it will be A, and that's because that will be the layout of the keypad that I will be using later on. So let's just continue like this with all the R keys, until we have all 16 of those. And I've noticed that some parts of those labels looks kind of strange, like for example this part of the 0 or maybe those double pixels on the A letter. And I did found out that if you change the anti-aliasing method from the none to, for example, the sharp one, and then you apply the threshold effect on top of it, it looks much better. So with that change, let's copy one of those labels and change it to be the pin label, so pin. And maybe let's add some icon, and you can of course draw it using the pen tool. But the U8G2 library also has a lot of icon fonts, for example this streamline one. So if I open it, there are quite a lot of icons. So let me try to find some with the locks and keys, which is this one, the Streamline Interface Essential Key Lock. So let me just copy this image into the clipboard and paste the image inside Photopea. And for this image, I will invert the colors by going to Image Adjustments Invert or just pressing the Ctrl-I. And I quite like this simple key icon without the circle, so select the selection tool and only select this area of the image. And then press the Ctrl-C and Ctrl-V to paste this image and hide the old one and move this key somewhere next to the pin label, like so. And I think that this could be our final design. So let's go to File, Export as PNG file and export it as a PNG file. And then to use it inside our sketch, we need to convert this image into the C-style array using the Image to CPP website. So select that image, scroll down to see the preview and make sure to check the swap bits in byte checkbox. Then click the Generate Code and copy the output. And I will jump back into the Walk with Simulation and try to replace this array with our new array. So let's just delete the content of this array. And if I paste the content from the clipboard, it will have some extra data which we don't need. So just delete this bottom part and delete this upper part. And if I restart the simulation, we should see our new image. So let's quickly try that on the real Arduino by copying the code into the clipboard. Then paste the code in here and click the upload button again. And we should see our new image on the OLED display. Now to make this functional, we need to separate those elements and draw them one by one, but we also need some keys, some buttons to input new values. And if I go back to the TEMU website, you can get a keypad like this one. But I've also found this keypad which not only has buttons, but also the OLED display. And you can get it with smaller OLED display or with bigger OLED display. So let me actually get both of those and see how they work, because this one seems to be using slightly different chip, being the SH1106, instead of our SSD 1306, which is the chip used for the smaller display. But if I jump into the U8G2 documentation and open the list of supported displays, the SH1106 with the 128 by 64 pixel resolution should be supported as well. But let's take a closer look at our keypad. It has 16 push buttons, but if I look at the pins on top of the PCB, we only have 12 different pins and 4 of them are used for the OLED display. That means that only 8 pins are used for those buttons. And that's because those buttons are connected in a way that one pin is used for every row and one pin is used for every column, and they are using what's called the multiplexing. Now I've described multiplexing in my older video, although I wasn't using buttons, I was using LEDs, but the principle is pretty much the same. You just scan through the columns and rows and light up those individual LEDs, or in our case, get the state of the button. So as the first step, let's go back into Walkway and add those buttons and connect them in the very same way. I will stop the simulation and add a new push button, and I will go with this smaller one for no particular reason and move it on the right side, maybe somewhere in there, and then create a few more copies. Actually 16 of those. And I want to connect all columns together, so connect all columns together just like that. And then I want to connect all the rows together, and I can use those 2 pins because those 2 pins are always connected inside those buttons. So just keep connecting those individual buttons. Now if I select the connection, I can use this menu to change the color of this wire. So let me actually do that to make it more understandable. And if I open the documentation for the button, I can actually add the label by adding the label attribute. So back in the simulation, I can go to diagram.json file, find the button and add the label property and set it to some value, for example number 1, and add the label for all the buttons. Then we want to connect those columns and rows to the Arduino digital pins. And we probably don't want to use pins 0 and 1 because those are used for the serial communication. But other than that, we can use any pins that we want. So let me just connect those randomly to the Arduino. In the end, we have the rows connected to pins 2, 3, 4 and 5. And the columns connected to pins 6, 7, 8 and 9. Now to get the keypad working, I will use the library called Arduino Keypad. So inside our sketch, I will click the library manager, click the plus button and type in Arduino Keypad and edit this library. And then I will open the GitHub page for this library and go to examples and open this keypad generic example and open the INO file. And somehow put those 2 sketches next to each other. And I want to copy bits and pieces from this keypad generic into our main sketch. So starting with including the library, so include the Arduino Keypad library. And then before the setup function, I will copy the number of rows, number of columns, and defining the characters on those individual buttons. And then the pin assignment for the rows and columns and initializing the keypad. So copy all of those lines into our sketch. Then inside the setup function, I will start the serial communication and initialize the keypad again. And then inside the loop function, it looks like that we are getting the states of those buttons. And if there is any change, we are getting the key that was changed. And if it was pressed, we will print some message. And if it was released, we will print a different message. So I'll just copy all those lines into our code as well. And we don't need this delay anymore, so we don't have to wait for anything. And I think that's all that we need from this sample sketch. But we still need to set the correct pins for those rows and columns. And if I take a closer look, the first row is this orange wire, which is connected to pin number 5. The second row is this yellow one connected to pin number 4, then the pin number 3 and pin number 2. And as for the columns, the first one is this white one connected to pin number 9, second one is gray one connected to pin number 8, and then 7 and 6. As for the labels for those individual buttons, it looks like that it's matching our keypad, so let's see what happens if I started the simulation. And we have a problem because it's saying that we don't have enough memory. So let's close this dialog and let's see how much memory we use by copying this code into the clipboard, then pasting it into the Arduino IDE and hitting the verify button. And the Arduino Uno has 32 kilobytes of flash memory. That's the place where we store the full screen background image, and we are only using 36% of the flash memory, so we are fine there. But it has only 2 kilobytes of RAM memory, and we are already using more than that. And the main reason for using so much RAM memory is the OLED display, because right now we store the entire 128 by 64 pixels, each pixel requiring 1 bit, so divided by 8 we get the byte value. We are using 1 kilobyte or 50% of the RAM memory just to store the buffer, the content of the OLED display. Thankfully there is a way how to lower the memory usage, and that is to switch the full screen buffer into the page buffer. And the UHG2 documentation has all the details in this section, so the full buffer versus the page buffer. Right now we are using the full buffer, so we are clearing the buffer and then sending the buffer to the display, but we need to switch to the page buffer, and for that we need a different kind of loop. So those lines of code, I'll copy this inside our sketch. And instead of clearing the buffer and sending the buffer to the display, I will call the first page function and then do all the drawing inside this do while loop. Now in order to use the page mode, we need to change the initialization line, and instead of including this F character, this F letter, I need to switch this to use the 1 for the page buffer. So let's try to restart the simulation now and see what happens. And it seems like that the simulation is running without any problems. So let's see what happens if I press any of those buttons. And as I do so, you will see that I see the message being the one pressed and one released. And if I press other buttons like 2, 3, or even A or asterisk, everything seems to be working as expected. We are getting those messages because we are printing those values into the serial port. But instead of printing it there, I want to show it on the OLED display. And currently we are only showing full screen background image, which means that we need to separate the image into individual elements. I will start by drawing this rounded frame, and if I open Photopea, I can select the layer and then click the distances checkbox to see the position and the size. And inside the UHG2 documentation, I will be using the draw R frame, the draw rounded frame function. So just copy this into the clipboard. I don't want to draw any image, but I want to draw the rounded frame, only position being 2 and 27, so x being 2 and y being 27, and the size is 60 by 24 pixels, and I want to use very small rounding, probably only 2 pixels. Now this outline is sized 2 pixels, and this function will only draw me 1 pixel rectangle, so I'll draw one more frame inside, so copy this draw frame function, and make it 1 pixel smaller, so the x will be 3, the y will be 28, and then the width will be 58 by 22 pixels. Now just in case, I will draw the setDrawColor function and set it to 1 for the foreground color being the white color, so just copy the setDrawColor function set to 1 and paste it before drawing those rectangles, and if I restart the simulation now, I only see the outline. So let's also add the other elements, starting with this icon, the key icon, and to export it from Photopea we can do it in a few different ways. What I like to do is to name the layer -e- and then go to File, Export Layers, and if I click this checkbox, it will only export me layers which starts with -e-, so click the Export Layers button. And I need to again convert this PNG image into the C-style array using the Image to CPP website. Just don't forget to click the Swap checkbox and then click the Generate Code and copy the output and paste the code inside our Arduino sketch. But I want to draw this image and I should have the drawXBMP function in there, so just copy this one. And we just need to change the name of the array, which is this one, and the size of the image, which is 17 by 8 pixels, so 17 by 8 pixels. And if I open Photopea, I can also see the position being 12 for both x and y, so x and y should be 12. And if I restart the simulation now, I do see also the icon. So now we want to draw the labels, being the pin label and the big label for the actual code. And back inside the UHG2 documentation, we will be using the drawString function. So let's just copy both lines for setting the font and drawing the string inside our code. And as for the font name, we are using the font name Pro Font. We just need to select the correct size. And for the small label, I was using the Pro Font in the size 11 points. And there are different versions of the font. The one ending with F is a full font, the R is reduced, and the N is just the numbers. And I think in my case I will go with this one, so U8G2 font Pro Font 11 TR. Just remember the name and type it in here, so U8G2 font Pro Font 11 underscore TR. And we want to print out the label pin. And as for the position, I can see it's 33 and 13, but for labels, actually the Y position is based on the baseline, which is this bottom line. So the Y will be 13 plus 7, so it will be 20 instead, so 33 and 20. And let's quickly restart the simulation. And then for the big label, for the big code, we want to use a bigger font, and I will be using the font in the size of 22, which is this one. And just because we have the ABCD characters, we want to use again the R font, the TR font. So just copy those two lines, and instead of printing pin, I will print 1, 2, 3, 4, and the font should be sized 22. And as for the position, if I select the layer in Photopea, the X is 9, and the Y should be 32 plus the height of the font, which is 14, so it will be 46, so it will be 9 and 46. And let's restart the simulation one more time. And we do see the big label on the display, on the OLED display. And I would say for now, let's not worry about the visualization of the keypad on the right side of the display, but instead let's make those buttons clickable, meaning let's update the code on the OLED display. So instead of drawing the fixed string, I want to draw a variable, and I will create a new variable and call it pin code label. And that should be string, that should be the array of characters, and I want to have 5 different characters, because I want to have 4 different characters for the code itself, but I need to include the last one, the 5th one, the null character that will set the end of the string, the length of the string. So anytime you want to create the C-style array string, you need to make sure that you are including the last character for the null character. And I will set the content to be just all dashes, like so, and then draw this pin code label instead of 1, 2, 3, 4, and restart the simulation. And sure enough, we see those characters on the OLED display, and I want to update those characters when I press those individual buttons. And here is the code that's doing that. So if I release the button, let me just put those inside brackets. If I release the button, I not only want to print the serial message, but I want to update the pin code label, and I will update the first character, so the character with the index of 0. And that will equal this one, so the E-bit key. So this is the key that is being pressed, and I will just set it to the first character of the pin code label. And let's restart it one more time. And let me just make it slightly bigger. And now when I press the button, I should change the first character inside our code. And I can press any other button, and I will be still changing the first character inside the pin code, which is not what I want. I want to change the next one, and so on and so on. And for that, I will create a new variable, and I will call this pin code label position and set it to 0. And the type could be, for example, byte. And that will be the position that I will be changing inside this pin code label. And once I change it, I want to increase it by 1, but at some point it will be bigger than 4. So if that happens, if the pin code label position is bigger than 4, in that case, I want to reset everything. And I want to set the pin code label to be again all dashes, but I cannot say that the pin code label equals 4 dashes, because if I do so, if I restart the simulation, I see the error because I'm trying to assign the value to the array. Again, the pin code label is the array of characters. So I can, for example, use the string copy function, or simply set the individual characters, which is something that I will do. So set the first character to be the dash, as well as the second one, the third one, and the fourth one. And just to be sure, I will set the last character, the one with the index of 5, to be 0, the null character, that will set the end of the string. So let's restart the simulation one more time. And if I press those buttons now, I should be setting the first character, the second one, the third one, and the last one. And when I press anything at this point, it will reset to the default state, which is not the case because it looks like that I cannot count up to 5, so it's 0, 1, 2, and it should be of course 3 and 4, not 4 and 5. So let's do it one more time. And hopefully now it will work, so 1, 2, 3, and 4. And if I press anything now, it will reset to the default state, and I can even enter A, B, C, D. And I can even enter asterisk or anything I want to. So I think that at this point it might make sense to test it on the real Arduino with the real keypad. So let's just copy the code into the clipboard. Then open the Arduino IDE, paste the code in here, and if you have never used the Adafruit keypad library, you have to go to libraries and install the Adafruit keypad library, and then we can press the upload button. Now what I haven't told you is that I haven't set the connections between the keypad and the Arduino randomly. I've tried to do it in a way that when you hold the keypad like that, it will be somehow aligned with those pins. So the rightmost pin should be connected to pin number 2 and the next one to 3 and 4 and so on, with the exception of the OLED display, which should still be connected to pins A4 and A5. So with everything connected, I can start pressing those buttons and it should work in the very same way as inside the VOCVIZ simulation. And it seems to be the case, it works without any problems. So let me do one more thing inside our code, and that is to draw the actual visualization of the keypad on the right side of the OLED display, and we will also show which button is currently being pressed. So let's jump back into the Arduino IDE, actually into the VOCVIZ simulation. And in here I want to draw the keypad layout on the right side of the OLED display, and for that I will be using the very same font as for the pin label. So let me just draw something, for example the digit number 1, and I know that the position should be 80 and 16, and I restart the simulation. And the digit number 1 is there, but I want to use the value from the actual layout, so from this array named keys. But if I try to do so, if I try to use the keys value inside the drawing function, so the keys of the column being 0 and the row being 0 as well, nothing is being drawn on the display, and that's because this array is the array of characters, but we need actual string, so array of characters, but in the form of string, not just referencing only one character, if that makes at least a little bit of sense. So I will create a new string and call this button label, and we only need 2 characters, one for the actual label and the second one for the null character to set the end of the string. And so inside our loop function, what I will do is I will just set the button label, and I will set the first character and I will set it to the value of the array of keys, and then draw this button label inside the draw function like so. And if I restart it one more time, I can again see the digit number 1 on the right side of the screen. So what I need to do is to just put everything inside the for loop to draw 4 by 4 characters. And instead of calculating the position inside the draw function, I've created 2 more variables, being the x position and the y position. So let's see what happens if I restart the simulation. And sure enough, we can finally see those individual labels, but when I press those buttons, I want to see the outline of the button, I want to see the button highlighted on the right side of the screen. And that should be as simple as drawing the rectangle below the actual character, but we need to first keep the state of those buttons, and for that I will create a new variable inside this keypad section, and let's do it as the array of bytes and call it button states, and it will be a 2-dimensional array similar to keys, so having the rows and columns for those indexes. And then when we are getting the state of those buttons, if the button is being pressed, and let me again put this inside brackets, so if the button is being pressed, let me just add the comment in here. I want to update the button states variable, so the button states, but I need to know the row and column, and thankfully there is a way how to do that. If I get the e.b.row, so e.b.row, that will be the row of the currently pressed button, and if I do the same in here, so e.bit.column without the s character, that will be the column for the currently pressed button, and I want to set it to 1, so the button is being pressed. And when the button is being released, I will do the similar thing, but this time I will set the value to be 0, so it's not being pressed anymore. Then when I'm drawing those individual labels, so around here, I want to see if the button is being pressed, so if the button states with the index from our loop, so j and I, if the button is being pressed, meaning if it equals 1, in that case I want to draw the rounded frame, so UHG draw rounded frame, but instead of drawing the frame, I will draw the rounded box, and the difference is that the box will be filled. And as for the position, I will use the x position with some kind of offset and the y position with some kind of offset, and I know that the size should be 11 by 11 pixels, and I can keep the same rounding. So let's restart the simulation one more time. And sure enough, when I press the button, I do see the background rectangle, but it looks kind of strange, and that's because we are drawing those labels non-transparent. And if I jump into the documentation, we have a few different font modes. We can draw the labels transparent or not transparent, and there is also the setDrawColor function, and with this function we can use the XOR mode, so inverting the background color, which is this last example, and that's something that I would like to use. So I'll just first use the set font mode to 1 to draw transparent fonts. So before drawing the label, I will call the set font mode and then set the draw color to be the value of 2. So again, value of 2. But once we do everything, I will just change it back to 1 to be the foreground color, the white color. So let's run the simulation one more time. And now we should see proper highlights for those buttons, and when the button is being pressed, the rectangle is white while the label is black, and that's again because we are using this XOR mode to invert the color of the background. So let's try to run this again on the real Arduino by copying the code into the clipboard, then paste the code into the Arduino IDE and hit the upload button. And sure enough, I now see the visual representation of the keypad on the right side of the display, and when I press the button, I see the button being highlighted. So let me quickly try a few more things, and one of those things is trying this keypad with the bigger OLED display. And as mentioned in the beginning of the video, this display is the same resolution but a different chip. The smaller one is using SSD 1306, while this bigger one is using the chip SH1106. And while those two chips are very similar, they are not the same, so when I connect the keypad, I do see the content, but it's not 100% correct. There is something going on the right side of the screen, which means that we need to go back into the Arduino IDE. And this is the initialization line for the used display, again having the 128 by 64 pixel resolution, using the SSD 1306 chip connected using the hardware I2C connection in the page mode, which is this number 1. And I need to use a different initialization, so open the U8G2 documentation and go to the supported displays. And in here I will search for SH1106 in the 128 by 64 pixel resolution. This is the SPI connection, so scroll down until you find the I2C connection, which is this section. And again we are looking for the hardware I2C with the number 1 for the page mode. And I think that this will be the correct one, so I'll just copy this piece of the code and paste it in here, and then copy the rest of the code and comment out the first line, and try to upload this sketch to the Arduino one more time. And now we should see the content of the OLED display without any problems or errors. So let me do one last thing, and that is to power this project using batteries. And that's because on the TEMU website I have found this module, and you just put the 18650 batteries inside, and then you can get 5V and 3V outputs, plus you can use the USB cable to charge those batteries. And I did get the version for 1 battery and for 2 batteries. And using it is quite simple, you just use the USB port to connect the Arduino board to this battery pack, and it should work. Now as for how long this will work, I also did get those batteries from TEMU, and it's saying that they have 2200 mAh. So the battery capacity is 2200, but I have 2 of those, so it will be 4400. And I've measured the consumption of the Arduino board with the OLED display to be around 30 milliamps. So it should be around 146 hours, but that's actually not the case, because those batteries are 3.7 volts, while the Arduino is 5 volt. So let me just do the equation. So 146 hours divided by 5 volts multiplied by 3.7 volts. And it looks like that we should be able to power the Arduino for about 100 hours. And that's it for today. If you have any questions or comments, please put those down in the comment section. As usual, all the source files are on GitHub. The link is in the description. Thank you very much for watching, and I hope to see you soon. Thanks and bye.